Bismillahirrahmanirrahim. Welcome to the new lecture of discrete mathematics. So today we are going to study about the discrete probability. So the discrete probability and probability theory. So as you guys know about a probability, that let's say you have a dice and you are flipping your dice and you can see what's come 1 2 3 4 5 6, like in a ludo you are playing a ludos, and a ludo you can see it. So this is kind of this is know about a probability. You want 6, so and you are flipping a dice 6 times, so you can see how many times 6 can be appear in a dice. So this is called probability. So in a real scenario, we have some theorem for a probability. So how and which kind of probability can be solved by different theorem. So the first one we are coming to, that is finite probability. In a finite probability we have some definition and some concept. The first one is Laplace definition. So what Laplace definition can say? Experiment. So what is experiment? A procedure that yields one of a given set of possible outcomes. Simple again. You have a dice, or you are playing a ludo, and you are flipping your dice in air, and you can see how many times 1 or 2 or 3 can appear. So this is called a possible outcome. Or whenever you are playing cards, when you are playing a cards, and then you can see how many times king can be appear and joker and so on. So this is called the possible outcome can be appear. This is called experiment. Experiment mean basically experiment. What experiment mean? That you have something in your output. When you are doing something, you are making a programming, you are doing something, and at the result you have some reasonable output. This is called experiment. Then we are coming to sample space. Sample space means everything you have in the shape of a sets, that's called sample. Like universe is kind of a space. Okay, so just keep in mind universe. So universe mean each and every single thing is included in a space. So sample space means the set of possible outcome from the experiment. Okay, now coming to event. Event mean like you have a space now. Okay, like the universe is a space, and in a universe what we are doing, we are making events. Making event mean we are enjoying our life, we are playing, we are working, we are studying. So this all kind of a thing is like a events, making a events in your life. So event mean a subset of a sample space. So again the same thing, let's see. This is your sample space, and you are taking a small part. So this is a subset of a sample space, and this is called event. Okay, so hope this will help you now. The difference between sample space and event, this is an example. Okay, so let's come to our definition for the probability now. If S is sample space, if S is a finite sample space of equally likely outcome. It means when you are flipping your dice in a ludo, so it means 1 2 3 4 5 and 6, they are appearing equally. Mean 1 can appear 1 time, 2 can appear 1 time, 3 can appear 1 time, 4 can appear 1 time, up to 6 it can appear 1 time. This is called equally likely outcome. And E is an event, and E is an event. Event means sample space means you have 1 2 3 4 5 6 from 1 to 6 is your sample space, and now once 1 can appear, it's your one event. When once 2 can appear, it's your second event, 3 appear, 4 appears your event. So and E is an event, that is a subset of S, then the probability of an event is probability of E. You can be write like that. Probability of E or probability of event is always equal to the so magnitude of E divided by sample space. Okay, so just simple, let's see, we can say like one can appear one time. Okay, just simple taking one. So how many event we have? One just. And what was the sample? 1 2 3 4 5 6, so 1 over 6. So one can appear one time, so it means 1 by 6. This is your probability. Simple. If you are talking about 2 can appear one time. Okay, 2 can appear one time, sorry, 2 can appear one time again, so 2 can appear one time, this again 1 by 6, and then like 6 3 can appear one time, 4 can appear one time, and so on. If you can do 2 times, it can be 2, it can be 3 4 5. Okay, so it's based on your sample and it's based on your event. So let's come to some theorem. The probability of a combination of events, or the theorem number 1, let E be an event in a simple space. The probability of the event E, the complementary event of E, the complementary, just keep in, the complementary event of E is given by this formula. P of E is equal to 1 minus probability of an event. If you know about a complement in your digital logic design, it's simple, just same like a complement of a bit. So this is called complementary of event E is can be solved by this one. Come to the other one, theorem number 2. Let E1 and E2 be events in a sample space as then E1 and E2 be an event in a simple space. Like we have a one sample space and we have a two different events, E1 and E2. Then we can say probability of event 1 union event 2, which is always equal to probability of E1 plus probability of E2 minus probability of E1 intersection E2. This is basically a formula where we can use it out. Later on you will see an example, so how we can use it. Okay, so now let's come to this one example. There are many lotteries now that award enormous prizes to the people who correctly choose a set of 6 number out of the first n positive integer, where n is usually between 30 and 60. What is the probability that a person picks the correct number of out of 40? So if you can see, we have like a combination now. How many out we need to have? 6. From how many? 40. So just like combination, from 40 we need 6. So then we can be used like that. What should be the combination? We can say we can be have total number of values is 40, and how many outcome we need to have? 6. So simply you can use the formula of combination. Now how you can use, let's see. So one will be, first of all you need to solve for this one, then divide by, so you can know how you can solve 40 factorial divided by 40 minus 6 whole factorial into 6 factorial. So open it up to 36. When you open it up to 40, 39, 38, 37 and 36, so there will be 36, 40 multiply it up to this, and 36, and this 36 is going to be divided, 36 is going to be add. So at the result you have 40, you have 39, you have 38, you have 37, and divide by 6 factorial. So now you can solve it. 6 factorial, like 6 multiply 5 multiply 4 3 2, so it can be up to 7 something like that. Then divide it, so you will have a this value, so you will have a this value, then 1 divided by this value, you will have a this outcome. So this is basically a way how you can solve it. Simple method, simple thing. Okay, it's just is like a probability. Now probability, you can see probability of 40 into 6, which is like a combination. So this is your answer. So now coming to another example, the second example can say, what is the probability that a positive integer selected at random from the set of a positive integer not exceeding 100 is divisible by either 2 or 5. So now we have a 2, 5 and 100. Just keep in mind now 2, 5 and 100. So where we had a formula, just keep in mind now this formula that we have a 2 event 2, 5. Okay, so up to 2 event we need to use this formula. So initially whatever you need to find out for PE1, then for PE2, then this one, then at the end we can add and subtract. Okay, initially we have a 2. Okay, so we can be like probability of 2 can be 1 over 2, 1 over 2 can be equal to 0.5. Then we have a 5, then 1 over 5 which can is equal to 0.2. So E1 and E2. Now come to this one. This is more important now. So according to this formula, so we have 100 which is divisible by 2. So when 100 is divisible by 2, so how many possibly we have 50, like 100 divided by 2, 100 divided by 4, like this, 2, 4, 6, 8 and so on. So how many possibly we can have? We can have 50 possibilities. Then when 100 is divisible by 5, so how many possibly we have? 10, 10, 5, like 20. Okay, so when 20 multiply 5, it can be 100. So 20 possibilities can from a 5 and 50 possibilities from a 2. So now we are going to take the common, because we have intersection. So in a when the 100 divided by 2, we have from 2 to 50. Okay, 2, 4, 6, 8, 10 up to 50, and the same concept apply for a 5 as well. So for a 5 up to 20. So now we can compare how many possibilities we have. It's just like a 10. So we have like intersection between PE1 and PE2, like a 100, like 2 if you can see, and 100 divided by 5. So once you are seeing the constant number which we divide the 100, it can be 10, because here we can have a 50 possibilities and here we can have a 20 possibilities. So when we are taking a common from 50 to 20, then we will have a 10 values. So the probability of a 10, it will be like a 1 divided by 10, which is equal to 0.1. and so use the formula P1 plus P2 minus P1 into E2, then you will have this answer. So this is another example. So hope you guys understood how it can solve, because like from a 5 to when we are dividing 100 by 5, so it can be like a 20 values, like 20 values. So and for a 2 we have a 50 values. So when we are seeing from 2 to 50, so 10 values which is same in a value of 5, which is same in a value of 2, like you 5 ones are 5, like 5 twos are 10, like same in in a wise. So you will have a 10 values. Let's come to another example. In another example, you get probabilistic region, the Monty Hall 3-door puzzles. Okay, so you are asked to select one of a 3-door to win the prize. How many door? 3-door by one of the 3. So it means 1 over 3 probability. So once you select the door, the host, who knows what is behind each door, he open one of the other 2 door. One of the other 2 door means 2 door it's going to open. So 2 by 3, because totally we have a 3 door and 2 door is going to be open, so it can be 2 by 3 that he know in a losing door. Then he asks you whether you would like to switch door, should you change door or keep your original selection. So you should change the door whenever you have a chance. Then the probability of a winning will change from 1 over 3 to 2 over 3, because of 1 over 3 to 2 over 3. Simple as this, but it's just totally a game of mind, how you can play your with your mind in a probability section. Coming to assigning a probability. So one thing keep in mind, that whenever you have how many events you have, but the summation of all the events, will always be equal to 1. It never be more than 1. So assigning probability mean Let S be the sample space of an experiment with a finite or a countable number of outcomes, finite or countable, which is noun. We assign a probability P of S to each outcome S such that these two conditions must be met. So this is two conditions for each and every probability section. Like the probability of a sample will always in between 0 and 1, in between 0 and 1, okay, not more than 1, not less than 0, okay. Then the summation of all the probability and a sample which always be equal to 1, not more than 1, again the same one. So the function of probability is called probability distribution. P of S can be P, it can be P of T, it can be P of F, whatever you can select a sample by the word, so it can be. So you have a P of S, let's see, and you are distributing P of S as I mentioned before, like this is your sample and you are distributing it into a subset. So this is called probability distribution, okay. Coming to the definition of, suppose that S is a set with n elements, the uniform distribution assign the probability 1 over n to each element of S. It like what does it mean? Like we have a total 6 element, like it's like a die, like 1 2 3 4 5 6, it's like a die. So the uniform distribution means that 1 can be 1 over 6, 2 can be 1 over 6, 3 can be 1 over 6, 4 can be 1 over 6, 5 can be 1 over 6, 6 can be 1 over 6. So this is called uniform distribution. Definition 2. The probability of the event E is the sum of the probabilities of the outcome in a E, what that is P of E, which is always equal to summation of probability of a sample which is S belongs to the event. So this is basically a formula which you need to have in your mind, and later on we will solve the example by using this formula. So note that when E is an infinite set, this is about finite now. When E is an infinite set, infinite is a conversion infinite series, so the conversion will be infinite. You will not know. Let's say you are flipping your dice infinite number of time. So infinite number, so one can be infinite, can be appear infinitely, because we are flipping, so it means it cannot be noun, okay. So coming to this example, suppose that a die is based so that 3 appear twice. So 3 appear twice, keep in mind, is often is each number, but that the other 5 outcome are equally like they, what is the probability that an odd number appear when we roll that. Let's say you have event, total number of event in a die, you know it can be 1 2 3 4 5 and 6. So we are talking about the odd, so in odd we take 1 3 5, and he said that 3's appear 2 times. So when 3's appear 2 times, so the probability of a 3 mean, the probability mean basically we have a 6, 1 2 3 4 5 6, but what we are saying that 3's appear 2 times, so it means it's going to be 7. The total sample will be equal to 7, and how many event can be occur? 2 for a 3, this one. Then he's saying that for P of 1, P of 2, P of 4, P of 5 and P of 6, it's appear 1 time, so it's equal to P of 1 over 7. So at the result, the probability of events, which is mean that how many, what is the probability that an odd number appear when we roll this. So what should be the probability of an odd number? So you know that 1 3 5 it can appear, okay, 3 1 2 3 3. Then what happened, we said that 3's appear 2 times, so 1 2 3 and 3 appears 2 times, it can be equal to 4, so the probability will equal to 4 divided by 7. Simple method how we can judge it out, okay. So the total probability for an odd number from a sample, but when we are but when the 3 is appeared 2 times, so the probability will be 4/7. Coming to the conditional probability and independence. So definition again, let E and F be an even when with P probability of is greater than 0. The conditional probability of the E given F denoted by this formula. So P probability of E slash F, which is P E intersection F divided P of. This is basically formula, and how we can solve I will show you later on. Then the another definition is the even E and F are independent, F and only FP E intersection F, which is equal to this one. So we have a two formula. Once the probability are going to be conditional, so this formula is going to be used. One, this is independent, so this formula is going to be used. Let's come to the example. So he's saying that what is the conditional probability? Which one? Conditional probability that a family with the two kids, has a two boys. Two kid has a two boy. Given they have at least one boy. They have at least one boy. Let's see, we are making two even now. Initial, let E is equal to 2 boy, B and B, boy. Okay, then we are making another, because they are saying that conditional, that family need to have at least one boy. It can be more than one, but at least one. So once we are making this kind of, so we can say like how many boys how many kids we have? 2. So if you remember the formula, 2 raised to power n, so total we have 2 raised to power 2. How many possibilities we have? 4. So in the 4, what we can do now? So boy it's happened. Now we need to at least have one. So for a section of F, we can say that it can be possible boy, it can be boy girl, it can be girl boy. Okay, so now if once we are taking the intersection between two event, so intersection of E and F, so what is the common? Boy. So this is your common now. So now come to this solution, boy. So P E slash F, which is equal to 1/4. 1/4 mean that boy can happen 1/4, and then at least one. How many possibility? Then 3/4. At the result we have 1/3. P E intersection F mean how many possibility we have? 1. So it means 1/4. Then come to this one, P of F, and a P of F, 1 2 3, so it will be equal 3/4. Solve it out. This is your required answer. So coming to another now, or the event E that a family with 3 kids now, family with that 3 kids, so 2 raised to power 3, how many possibility we have? 8. With the 3 kids has of both sexes, and F dates this family has at most one boy. It has most one independent. So this is about independent now, this formula. So P slash F, so PE and PF, so PE and PF, which is equal to 3/8, because it is independent now, and it's independent, so it's simple solution that equal to 3/8. So this is simple, that even E that a family have a 3 kid and has a both sexes, and both sexes mean like we can say that probably can be both sexes, like boy girl, girl boy, so it can be like a 2/8 we can say. Then we can plus, then he said that F that this family has at most one boy, so can be like the one boy added, so the result can be 3/8. So this is your formula, how you can solve it. So this was your lecture. So hope you guys find it well. Watch it out. If you have any question, that's your question, and thank you for your time. See you in the next lecture.